This video we will solve question number 7 of question number 1 under section A of ISC specimen question paper 2021. Identify from the given options the slope of the normal to the curve x square plus 3y plus y square equals to 5 at 1, 1. The options are minus 2 by 5, 5 by 2, 2 by 5 and minus 5 by 2. So here we have to find out the slope of the normal to this particular curve, and the normal is drawn at point 1, 1. So let us assume that our curve, so let us first of all write down the curve. It is x square plus 3y plus y square equals to 5. Let us assume that this curve looks something like this, and here is our point 1, 1. At this point our normal is drawn. Okay, so this is our normal. We have to find out what is the slope of this normal. We can consider a tangent which is drawn at this same point like this. This is the tangent. Now if we find out the slope of this tangent, we can easily find out the slope of this normal, because we know that the normal and the tangent are mutually perpendicular to each other. And if we multiply the slopes of the normal and the tangent, we will get minus 1. So let us first of all find out the slope of the tangent at point P 1, 1. For finding out the slope of the tangent at any point on this curve, we know that we have to differentiate both sides with respect to x. So differentiating both sides with respect to x, we get 2x plus 3 dy dx plus 2y dy dx equals to 0. From here, let us make dy dx as the subject, and we get 3 plus 2y equals to minus 2x. Then we can write down dy dx equals to minus 2x whole divided by 3 plus 2y. This is the slope of the tangent at any point on this curve. Now we want to find out what is the slope at point 1, 1. This is the slope of the tangent, this particular tangent, at the point 1, 1. So that gives us 2 divided by 5. Let us draw a margin over here. We will continue the rest part of the sum over here. So this gives us the slope of the tangent. Let the slope of the tangent at point 1, 1, within bracket let us consider this as m1 equals to minus 2 by 5. Therefore, slope of the normal within bracket let us consider this as m2 can be found out as m1 into m2 equals to minus 1. Or what is m1? Minus 2 by 5 into m2 equals to minus 1. From here we get m2 equals to 5 by 2. Therefore, the slope of the normal is equals to 5 by 2. Hence our answer is option B. Hope this clarifies the question. In this video, we will solve subpart 9 of question number 1 under section A of ISC specimen question paper 2021. The question goes, the function fx is equals to sin x plus cos x, where x belongs to open interval of 0, pi by 2, then maximum value of fx is. The options are 1, 2, 1 by root 2, root 2. Now this sum can be done in two methods. One is with the help of maxima minima and the other with the help of graph. So let us see method 1. We have fx equals to sin x plus cos x. Now, according to the rules of maxima minima, if you want to find out the maximum or the minimum value of any function, we first of all differentiate that function with respect to x and we equate it to 0. So for calculating the maxima, differentiate fx with respect to x and equate it to 0. That means f dash x equals to 0. So by doing this, what we will get? Derivative of sin x is cos x. Derivative of cos x is minus sin x. That is equals to 0. Or if I take sin x on that side and cos x in the denominator, we get 1 equals to tan x. Or tan x is equals to tan pi by 4. Although tan has value 1 in different angles as well, but since our our domain is the open interval of 0 and pi by 2, therefore we will take x as pi by 4 only. Therefore x equals to pi by 4. Now to ascertain whether this pi by 4 is the maximum or the minimum value, we differentiate fx once again with respect to x. So we already have f dash x, we will find out f double dash x, and that will give us, so f dash x is cos x minus sin x. If we double differentiate, if we again differentiate, we get minus sin x. The derivative of cos x is minus sin x and derivative of sin x is cos x. So that gives us minus sin x minus cos x. Now the value of second order derivative at x equals to pi by 4 is equals to f double second order derivative or double derivative at pi by 4 will give us 1 by root 2 minus 1 by root 2, and that is 2 by root 2, and that is minus root 2. So we can see that if double dash or the second order derivative of fx at x equals to pi by 4 is actually less than 0, which ascertains us that fx is maximum at x equals to pi by 4. Now we have to find out the maximum value of fx at x equals to pi by 4. That we can do it here. Let me draw a straight line over here. So this is a continuation part. Therefore f pi by 4 will give sine pi by 4 plus cos pi by 4, and that will give us 1 by root 2 plus 1 by root 2, and that will give us 2 by root 2, and that is root 2. So from the options we can see that option D is the right answer. So answer is option D. This is method 1. Now let us see method 2. Let us take a y-axis and let us take an x-axis. Now let us mark the points. It is 0, and then we have pi by 2, and then we have pi, then we have 3 pi by 2, and so on and so forth. Now let us draw the graph of sin x. We know the graph of sin x starts from 0. Yeah, so let us draw it in black only. We know the graph of sin x. Value of sin x at x equals to 0 is 0. Value of sin x at x equals to pi by 2 is 1. So we make the value 1. Now we will make our graph only till here, up to here. Now let us see how cos x looks like. Now we know the graph of cos x starts from maximum value at 0. Value of cos x at 0 is 1. So in this case, the graph will start from here. And the value of cos x at pi by 2 is 0. So it will come down like this. Now we can see that fx equals to sin x plus cos x. So let me write down the values. This is sin x graph and this is cos x graph. Now as we can see, fx equals to sin x plus cos x is the superimposition of these two curves or two waves we can see. So if we superimpose these two waves, the only meeting point or the only maximum value that we will get is at this point. At this point we can see that sin x and cos x both meet each other. That means they equate each other. And in that case tan x equals to 1, therefore x equals to pi by 4. So therefore the maximum value of fx is obtained at x equals to pi by 4, which is root 2. Hope this clarifies the question.